Hey guys, welcome to the local host lab, and today we'll see what are solid principles from system design perspective. This is the basic that everyone should know. So first, let's see what are solid principles and why do we need solid principles, and we'll see some code snippets to better understand a bad code, a bad design from a good design. So solid principles are five design guidelines in object-oriented programming. So this helps developers to create software which is easy to maintain, scale, and understand. So why these principles are needed? Because they make the code base very modular and easier for teams to collaborate. And the software can evolve over time. So when you're working in an enterprise, there are very big teams and there has to be certain guidelines that needs to be followed by every team member. This ensures that the code base is modular, it's more readable, scalable, and easy to maintain over time. So solid principles, so SOLID, so each letter is a principle. So first we'll see the S or the SRP, single responsibility principle. This states that a class should have one and only one reason to change. One class is equal to one responsibility. Every class should have only a single responsibility. Next O is open closed principle. So our classes, so software entities, which means classes, modules, or functions, they should be open for extension but closed for modification. We should be able to add new functionality without changing the existing code. So we'll see with code example, then this will become more clear to you. Then the next is Liskov substitution principle. Now, objects of a superclass should be replaceable with objects of its subclass without breaking the application. Essentially, a derived class must enhance the parent class's behavior, not ruin it or change it in a way that requires the user to know which specific subclass they are using. So, if a child is inheriting from a parent class, the child should extend the parent's functionality and not restrict it. This we'll see in the code example again. But for understanding, getting the context of what this principle is, the child should always extend the parent's capability and not restrict it. Then interface segregation principle. This is the one of the very basic principles, and which states that an interface should uh, should be specific and not very large and fat interfaces. It is better to have small interfaces. Then we have dependency inversion principle. So this is required for making your system loosely coupled. This decouples our code, and basically what we are doing is this principle is dependent on abstractions. So it is easier to change the implementation. Now, after discussing these five principles, I hope the context is clear. Now we will see these principles in action. So I have written few classes. So we have a bad design and then we improved that design using these principles. So first, let's see for single responsibility. We have a we have an service class, an order service class, and we are doing a lot of things in this service class, we are creating order, then we are saving to database, then we are sending email. Now, this class doesn't have a single responsibility. We are doing a lot of things in a single service class. So this breaks the SRP. Now, this is a bad design. If we have to make it a good design, then we would have to write it something like this. So what we'll do is we will have only one method, which is create order, and we are injecting the repository and the email service class, and then we are calling its method. So this class is focused. It is only creating order and nothing else, compared to this where we are creating the order, saving to database, and sending email. Let's move to open closed principle. Open closed principle was open for extension but closed for modification. So we have a payment service class and we have a method called process payment. Now we have card, UPI, net banking, and we have if else if conditions. If my payment type is card, do something. If it is UPI, do something. If it is net banking, do something. Now tell me if there is another new payment type which needs to be implemented, how are we going to do it? We have to write a new condition, payment type dot equals, let's say, wallet. Processing wallet payment. Now we actually modified this class. We are modifying this class, which is breaking the open close principle. Now, this is a bad design because we have to make changes to a service class. So, what is a good design? So, what we have done is we have created an interface payment which has method pay, and then we have different uh, payment method types like card payment, which is implementing this interface UPI payment. Now, suppose if I have to suppose there is a new payment type called as wallet. So, what we'll do is we'll simply create a new class which will also implement this payment interface and out processing wallet payment. Hmm. And we can inject this interface wherever we want to call this pay method. So what happens now is key in case of new payment uh, type, we can always create a new class and implement this uh, interface. So we are not modifying our service class by writing else if conditions, if else condition. So this is the open closed principle. Now we'll go to Liskov's principle. Now suppose we have an interface called as bird, and there we have a method called fly, and we have two birds. Sparrow, it is implementing bird interface, and penguin. So sparrow, for sparrow it's fine. Sparrow flies, right? Whereas penguin, they don't fly. Even though they are birds, but they don't fly. So we are throwing an exception. So what is happening? Our child is restricting the parent's capability. It is not extending, it is restricting, because parent has a fly method, but penguin doesn't. So it is restricting the parent's capability, right? So this is a bad code design. This interface itself is designed badly. So what is a good design? So we have a class called as bird. We can have eat, sleep, all these methods in this, like any number of methods like void, eat. Okay, all birds eat, right? Void, sleep, all birds sleep, right? And we have created capability interfaces like flying capability and swimming capability. Now, Sparrow, Sparrow extends bird. Now, Sparrow has all the methods of bird, which is eating and sleeping, and Sparrow is also implementing flying capability. Bird is flying. Whereas penguin, it is also extending bird. It can also sleep and it can also eat, and it is implementing this swimming capability. Penguins can swim. So this, so our child, they are extending the parent's capability and not restricting it. This is what Liskow's principle is. The next is interface segregation principle. Now suppose we have a big we have a big interface. Now this interface only has two methods, work and eat, but we have different concrete classes. Human worker do work and eat, whereas robot worker, they don't eat, right? So we have to throw an exception. So what we have to do is we can segregate the interfaces into separate specific interfaces like eatable and workable, and human can implement both these interfaces, eat and work. Robot can only implement workable. Another example is this Liskov's. कि यहाँ पे the मतलब यहाँ पे तो there is only one interface, but what we have done is we have created specific separate interfaces. So this is also an example of interface segregation principle. Now last, which is the dependency inversion principle. So suppose we have a service class, right? And this class is creating a an object of this class MySQL database, and it is calling its save method. Now this in this class, this MySQL database is tightly coupled. See, this is tightly coupled. There is no abstraction. So this is a bad code design. We want to keep our system as loosely coupled as possible. Why? Because we want to achieve abstraction. We want to inject interfaces into our service classes instead of concrete classes. Why? Because suppose our implementation changes, what we can do is we can make changes into our concrete class without affecting the client class. So this user service is the client class, and it is it has an object of this class, right? So this is a bad code design. What is a good code design is we have a database interface, okay? And we are injecting that interface into a service class, and we are calling its save method. And this interface is implemented by two databases, MySQL and PostgreSQL. Now, suppose if we want to use a MySQL database, we can simply, in the main method, we can create an reference for this, and we can create an object for MySQL database. We can create an object for user service, and we can register the user. Okay, we can pass this in its constructor. Suppose if I want to use the PostgreSQL, I only have to create the PostgreSQL and pass this in the constructor. So this approach is loosely coupled because we are using abstraction here. We are not concerned with the concrete classes here. There is no dependency. So this is what solid principles are, and I hope you understood the principles well with these code examples. And do subscribe if you liked the content.